Okay, so this is section 7.4, and it's on graphing reciprocal functions. Okay, and in general, a reciprocal of a function is basically you could be given like a function like y equals f of x, and this section here, what we're going to do is, let's say you know how to graph this function. What you're going to do is you're going to learn how to graph like the reciprocal of the function that you have. Okay, that's what the whole lesson is about. So anyways, let's begin. First of all, what's a reciprocal? Okay, so just to make things easier, suppose you had a number like a over b. A reciprocal is where you take the number, like a fraction here, and you flip it, where the bottom goes on top, so b, and the top goes on the bottom, so b over a. So for example, if you have like 4, it becomes like 4 is like 4 over 1, so it becomes 1 over 4. Or if you have like 5 over 3, it just becomes 3 over 5. That's a reciprocal of the other number, okay? So anyways, a reciprocal, again, if you want a definition, is where you switch the top and the bottom, the numerator and the denominator with each other, okay? Another thing is when you do the reciprocal, it doesn't change the sign, okay? If it's positive, it stays positive. If it's negative, it stays negative, all right? So here we go. First example, okay? What's a reciprocal of each of these numbers? So the first one's 10. So 10 becomes 1 over 10 because like 10 is like 10 over 1. Next one's half, 0.5. So let's do it anyways. So half is like 1 over 2. So reciprocal of 1 over 2 just becomes 2 over 1. So reciprocal of 2 is reciprocal of half is 2. And if you look at this one here, if you look at 1, the reciprocal 1, it's like 1 is like 1 over 1. You do the reciprocal, it stays as 1 over 1. So the reciprocal of 1 stays the same, okay? So let's write this down, okay? So reciprocal 1, it stays the same, okay? Now the 10, on the other hand, became smaller, like 0.1. So like a big number like 10 becomes smaller, and then a small number like half, it becomes bigger, bigger. Okay. Next one is 0. Okay. When you take the reciprocal of 0, it becomes undefined because anything divided by 0 becomes undefined. And the next one, so becomes undefined, and then negative half becomes negative 2. So remember what's negative? If it's negative, it stays negative. Okay? It's just that if it's like a number less than between 0 and negative 1, it gets bigger, it becomes negative 2. Next one's negative 1. So reciprocal of negative 1 stays as negative 1, so this one stays the same. Okay? So from this example, there are 3 main points you need to remember, okay? And the first one is the reciprocal of 1 and negative 1 will stay the same. Okay, that's actually quite important, okay? So any value of 1 and negative 1, you take the reciprocal of them, they don't change, they stay the same. Next one is the reciprocal of 0 is undefined, okay? That's also another key point. Make sure you put a star next to it. And last one is, hey, if you take a number between 1 and negative 1, and you take the reciprocal of it, it becomes bigger, larger, right? So for example, if you have like 0.001, and you take the reciprocal of it, it becomes 1,000. So from 0.001 to 1,000, it got bigger, okay? And on the other hand, if you take a big value, like let's say 1,000, let's say the bottom is 1,000, and you take the reciprocal of it, it becomes smaller, okay? So the rule for the third one is, I want you to remember that big numbers become small, and small numbers become big when you're taking the reciprocal, okay? All right, here we go. So for this slide here is defining, well, what happens when you take the reciprocal of a function, okay? So for example, let's say I have a line. A line has all these points, right? And what I'm going to do is I'm going to graph the reciprocal of this line. So what happens is all these points change and the graph becomes different like that, okay? So anyways, for this slide here, it's asking you, so if this is my equation, y equals 3x plus 11 is your equation. It's a line equation, right? What's a reciprocal of this function? And simply it just becomes 1 over the original function, so 1 over 3x plus 11. So therefore, if your original equation is y equals to 3x plus 11, the reciprocal function would be y equals to 1 over 3x plus 11. That's all the same. So whatever you have, you put a 1 above it. So for the second one, you see 8x squared minus 5x plus 13. The reciprocal would just be 1 over the original function. Okay? Let's move on. Okay, so how do you graph the reciprocal of a function, okay? So one of the key points is you have to remember is that when you're taking the reciprocal of a function, your y coordinates are the ones that change. So basically the x coordinates, okay, of graph, they stay the same. Okay, stay the same. And the y coordinate is the one that gets reciprocal. Okay, and I will go through reciprocal. Okay, I'll give an example. So let's say right now you have a line like y equals to x minus 2. Okay, and what I'm going to do is I'm going to fill in this table values. So when x is 1, y is negative 1. When x is 2, y is 0. When x is 3, you have 1. When x is 4, y is 2. When x is 5, y is 3. Okay, so this is the table values for this graph. And from this table values, you know that these points like 1 comma negative 1 is on this graph. Like 2 comma 0 is on the graph. 3 comma 1 is on the graph. And then 4 comma 4 and so on. Okay? Sorry, 4 comma 2, my bad. 4 comma 2. Okay, so these are points that are on the line graph. And then when you're graphing reciprocal, okay, and if you don't want to use the equation, just see that, hey, this point here is 1 comma negative 1. Okay? And then what you do is you leave the x value alone, and you take the reciprocal of the y value. So you see this is negative 1, you just go 1 over negative 1, and it just happens to stay as negative 1. Okay? So that what that means is this point became 1 comma negative 1. And the only reason why I stayed the same is because the y value is negative 1. Second one is you see 2 comma 0, so y value is 0, right? So for the reciprocal graph, it'll be 1 over 0. And 1 divided by 0 is undefined. So therefore, this point now becomes undefined. Okay? And 3 comma 1 stays as 3 comma 1 because 1 is a value where we take the reciprocal, it doesn't change. Now the next one is 4 comma 2. Y value is 2 right now, right? So the reciprocal of that will be 4 comma half. Okay? And then 5 comma 3 becomes 5 comma 1/3. So in general, if you're not sure what the rule is, if your x value is a and the y value is b, okay, so this point now becomes a, and then the x value stays the same, but the y value becomes 1 over b. Okay, so again, x values stay the same, and it's the y value that gets reciprocal. All right. So anyways, those are the notes there. Okay, so here are the steps. Okay, now this is actually your second step. Second step is, hey, the reciprocal 1 or negative 1 stays the same. So you look for all the points on the original graph where the y value is either 1 or negative 1. Okay? And so you label those as common points. Common points. Meaning like these are the points that don't change. Okay? And this is actually your first step. What you do is you find the reciprocal of 0 is undefined. So points with the y coordinate of 0 will become something called a vertical asymptote. So basically what's saying is whenever you have an x-intercept, these x-intercepts become a vertical line that you call an asymptote. Okay? An asymptote, in my opinion, is like electrical fence, a line that you cannot cross. But we'll get to it in a bit, okay? Here's your third step. You take the reciprocal of all the y coordinates to find out where the new function is. So in general, hey, if you have a bunch of large numbers and you take the reciprocal of them, they become smaller. And then when you have small numbers, you take the reciprocal of them, it becomes large. Okay? This is the hard one. Okay? This is the one where I'll probably need to explain a bit more. Alright? Okay, let's move on. Okay, so here we go. First one is, hey, you're being asked to graph the reciprocal of this graph. Okay, so first step, what I would do is, okay, let's graph the line first. Okay, the line from the bottom, okay? So y equals to 0.5x plus 1. You know the slope is half, so m equals half. And you know the y-intercept is 1, okay? So you see the graph here where, hey, the y-intercept is 1, the slope is half, so you go up 1, right 2, up 1, right 2, up 1, right 2, okay? And then you graph the line, okay? So there's my graph. Okay, now the next step is, let's find your x-intercepts. These are parts of the graph where the line right now, hits the x-axis. And you can see it right over here. This is the point where the x-intercept is, okay? So, or you can solve it algebraically. You take this line and you make y equal to 0. And you usually try to do this when the points aren't nice, okay? So you do the math, you move the 1 over, and then you divide it by half, you get x equals negative 2, okay? So this point over here is negative 2 comma 0, okay? And if you take the reciprocal of that, now you have something called the vertical asymptote. So this is your vertical asymptote. And the equation of this vertical asymptote is x cannot be -2. Okay? So here's the asymptote. So when you graph the reciprocal graph, it can never ever cross this dotted line. Okay, so next one is common points. It's when the y value is either 1 or -1. So when you look at the graph, okay, so this point over here, okay, has the y value of 1 because it's like 0, 1. Okay, and then down over here, there's another point where the y value is -1. So this is like -4, -1. Okay, so now you have your 2 points where the y value is either 1 or -1. Okay, so those are now your common points. And then usually what you have to do is you have to label the coordinates out like this. Okay, now here's the last step. Okay, so this is the third step where things become hard. So what you're doing is you're going to take some points that are on this blue line and you're going to get the reciprocal of them. Okay, so you see how 2, 2 is like right over here, 4, 3 is over here, and 6, 4 is over there. So if I were to graph my reciprocal, I have to take each of these points and then take the reciprocal of them. So 2, 2 becomes 2, half. 4, 3 becomes 4, 1/3. And 6, 4 becomes 6, 0.25. The x values stay the same. They don't change. But it's the y value that gets changed. So 2 becomes half, 3 becomes 1/3, and 4 becomes 0.25. So where do these points lie? Okay, so the first one is going to be right here. This is like 2, half, 4, 1/3, and 6, 0.25. And if you take out the points, like this one here is going to be like 8, 6. You take the reciprocal of that, it gets even lower. So you see how as the blue line goes further and further away from the x-axis, the reciprocal actually gets closer and closer and closer towards the x-axis. Okay, and the thing is, it will be getting so close but never touching it. Okay, and the common point is a point that the original graph and the reciprocal cross each other. Okay, now this is the hard part. Now I'm going to take some points that are really close to the x-axis, like right over here. Okay, and we're going to look at what's going to happen when you take the reciprocal of that. So -1, half is like right over here. So that becomes -1, 2. Okay, because the x is the same, it's the y value that gets reciprocal. Okay, and the next one is, hey, this point here is -1.5 and 0.25. So even closer to the x-axis. So that point becomes -1.5, 4. So that means that, hey, it'll be much higher. And last one is this point over here is -1.9. Very close to the asymptote and the x-axis, where the y value is 0.05, and then if you take the reciprocal of them, the y value becomes 20. So what you end up getting is, hey, like the point on the line that's really close to the x-intercept, when you take the reciprocal of it, it actually becomes really, really big. So your graph looks something like this. Okay, so again, what we're trying to do is we're graphing the reciprocal of that line. So that therefore this part will come from the top, come all the way down, hits all these other points, hits the common point, and eventually plateaus all the way towards the right, but never ever touching the x-axis. Okay, and same thing on the other side. You take these points that are really close to the x-axis, where it's really small, and then the reciprocal becomes something really far away from the x-axis, and your graph will look something like this. Okay, so there's that, and then the left side looks like that. Okay, so after you graph it out, a couple things you need to write down. What's my domain? The domain is x can be all real numbers except x cannot be -2. And for the range, y could be everything, all real numbers, except y cannot be 0, because the graph will never touch the x-axis. Okay. Alright, let's move on. So given this function, graph the reciprocal. So again, first step, find your x-intercepts. There it is. Number 2, find your common points. You know, there's one over here on top and one on the bottom. Number 3, pick some points and get the reciprocal of them. Again, just remember that, hey, when the points are like this, you see how the red line is going down away from the asymptote? It's going down, 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 down. So that means the reciprocal is going to come from, you know, somewhere over here. And it goes up, 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 hits the common point, and eventually plateaus all the way over to the right like that. Okay? And then same thing on this side. The graph goes up, 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 up on the left side. That means the reciprocal is going to come from the top, goes all the way down, hits a common point, and then plateaus all the way to the left. Right? So if you want, you can map the points on the graph. Okay? And again, all we're wanting is just a general sketch. The graph doesn't need to be perfect. Okay? So there's my graph. Okay? Okay. So I'm going to skip this one. All right. And then we'll continue on part 2 in a bit.